Okay, let's look at this question. Use the graphs to estimate the acceleration of an object when t is equal to 5. On a curve, we cannot measure gradient. We can only measure gradient of straight lines. We cannot measure gradient on a curve because if we pick any points, let's say this point, and that point, the gradient here and the gradient there and the gradient here are all different. So we don't know which gradient to choose. So there is a special method we use to calculate gradient at a particular point on a curve. If we want the gradient at this point, we construct a tangent at that point. If we want a gradient at this point, we should have the tangent at that point. If we want the gradient at this point, we should have a tangent at that point. So the key point is t is equal to 5. Now, on a curve like this, what we need to do is to draw a tangent at the point given. So t is equal to 5. We take a straight line from t, this is time, and then at 5. You bring it up like that. On this point, you construct a tangent. What is a tangent? A tangent is a line that just touches the graph at a point that we want, but does not go inside the curve. So this tangent, make sure you're using thin lines to draw a tangent. Okay, let's take this line right on the curve, but does not go inside the curve. It should just touch that point. Now your tangent must be long enough so that you can pick convenient points. What convenient points are we talking about? We have like this here, this point there. It's right on 2 lines. We don't want points in between these squares. We want a point that touches there, and we read off this value and that value. So for the x value, we have 9.24. This is a point we can clearly see, which is 9.4. You must understand the scale, because if this is 9, this is 9.2, 9.4, 9.6, 9.8, 10. So this point here is 9.4. And that y value, this is 20, 21, 22, 23, 24, 25. So here our y value is 24. So the coordinates of this point are 9.4, 24. X, y values. Then we look for another point that is convenient. It should be far from this point. Points should be well spaced. I can see this is clear. This point here is clear. This tangent is passing through that point. What are the coordinates of the point? So for the x value, we take this, and for the y value, we take that point there. So what is this point? 0, 0.2, 0.4, 0.6, 0.81. So this is 0.6. And that value is 5, 6, 7, 8, 9, 10. So this is 7. 5, 6, 7. So the coordinates of this point, we take the x and then the y. 0.6, then 7. Like that. Now to calculate the gradient at that point, we calculate the gradient of the tangent. So we'll say y value minus y value, 24 minus 7, over x value there minus x value there, which is 9.4 minus 0.6. Remember, it's an estimate. What they want to see is an attempt to draw a tangent and taking values of that tangent. The tangent may not be exactly like this. It may be a little bit off. Let's say this tangent there, you see, You can also work with this tangent. But as long as you are doing the right procedure, then they will mark. On a curve, put a tangent. Then find the gradient of the tangent. This can be worked out as 24 minus 7 over 9.4 minus 0.6, which is 1.9 meters per second squared. Acceleration is in meters per second squared. So that attempt to make a tangent, pick points along the tangent and work out gradient from those 2 points is what will earn you full marks. Okay.